Hello guys, in this video I am going to discuss a question which was asked last year in JEE Advanced paper B. Question was from calculus portion. Question is written on the screen. It says that if we have a real valued function from R to R which is as the product of three linear factors x minus 1 into x minus 2 into x minus 5, and there was and then we are calculating the area under this function f of x equals 0 to x f of t dt. And about this function, options are given that f has a local maxima at x equals 2, f has local minima at x equals 1 comma 5, f has two local max and one local min in 0 infinity, f of x is not equal to 0, x belonging to 0 to 5. So it involves certain concepts from the calculus like Newton-Leibniz formula and in intermediate value property for continuous functions. So we are going to solve it. Although these options are very easy to verify, you can easily deduce that about local max and local min property of this area function. We are actually calculating area under this curve x minus 1 into x minus 2 into x minus 5. But this fourth option is bit involved because it involves a property, intermediate value property of continuous functions. Actually that is a corollary of intermediate value property. Therefore if you have already studied Newton-Leibniz formula, you can simply calculate the derivative of this function f, capital F, and you will easily deduce that local max and local min property of this f by simply using first derivative test. If you calculate f dash of this capital, it will be simply f dash of x will be simply f of x. So let us verify first this property, first option. So f dash of x is simply f of x, which is actually x minus 1, x minus 2, x minus 5. So you can calculate, like if you have a function, if the tangent changes its slope from positive to negative, then we have a local maxima here. So therefore we are going to look in the left neighborhood of 2 and the right neighborhood of 2. We will see how the tangent changes its behavior. So f dash of 2 negative will be, this term will be first, it will be positive, second will be negative, and third will be negative. Therefore it will be overall positive. And f dash of 2 plus will be, this will be positive, this will be positive, this will be negative. Overall term will be less than 0. Therefore the tangent slope of the tangent changes from positive to negative. That is, at x equals 2 we have a local maxima. At x equals 2 we have a local maxima. Similarly you can verify for local minima. I am not going to do that, but we are going to look for the fourth option. That is, we have to prove that f of x is not equal to 0 in the interval 0 to 5. If you know a property for continuous functions, which says that if we have a continuous function, let us suppose in the interval a to b, and this is f of a is positive, let us suppose this is f of a, and here we have f of b, it is negative, then and if the function is continuous, it has to go continuously from f of a to f of b. It must cross at least once x-axis, which is the root of this function. Actually it may go like this, but at least it should cut x-axis at least once. So from this property we will deduce that f of x cannot be 0 in the interval 0 to 5. For this, if we will look at the graph of the derivative of this function, if we look, we have f of x and f dash of x is actually f of x, which is, let me write it directly, x minus 2 x minus 5. So you can easily graph this function. At x equals 0 we have minus 10 value, something negative value minus 10, and at x equals 1 2 5 we have roots of this function, and it will from minus 10 to 1 it will go like this, and it will increase up to certain value, then it will decrease, up to 0 because at 2 we have another root, then it will decrease up to certain extent, then it will increase further. So this is the graph of the f dash of x, and f of x is actually area under this curve. So therefore we have three portions of area here. One is this, and another is this, and another is this portion. We have three portion. You can easily see that this here from 0 to 1 f is already negative, f of x is already less than 0. Here you can already see, because area is here negative, because graph is below the x-axis, and here it is positive, and here it is still negative. Therefore if we have if the function here up to 2, if the sum of these two areas will be positive and this is negative, therefore it should cut x-axis at least once, that is it should have a root in this interval 0 to 5. But if you will calculate this area, that is if you will calculate from 0 to 2, if you will calculate, that is the addition of these two areas, this and this much, which will be simply this thing, x minus 1 x minus 2 x minus 5 dx, it comes out to be negative, it is less than 0. You can easily calculate it. This is 3-degree polynomial, and here it is also negative, therefore f of x is therefore f of x is less than 0 for all x belonging to 0 to 5. Therefore it cannot cross, it cannot cut x-axis in this interval, therefore it cannot be 0. F of x cannot be 0 in this interval. This fourth option was bit involved because it involves the concept of this intermediate value property. Continuous functions, rest are easy, you can easily deduce them. Hence we are done with this question. See you in next video. Thank you.